You know, an everyday substance, one that you'd find in just about any kitchen, can actually hold the power of a bomb. So today, we're going to break down how something as simple as sugar can become catastrophically explosive. And listen, this isn't just some abstract theory. It's a scientific principle with absolutely devastating real-world consequences. Because on February 7th, 2008, this exact phenomenon happened, and it unleashed a force that changed an entire community forever. You see, at the Imperial Sugar Refinery in Georgia, a catastrophic series of explosions just tore through the facility. Now, the fuel for this disaster, it wasn't dynamite or gas, it was just fine particles of sugar dust. The result was heartbreaking. 14 people died, 36 were injured, and the plant was completely destroyed. So our mission in this explainer is to pull back the curtain on the terrifying science behind these combustible dust explosions. And just as importantly, we need to understand the OSHA standards that are designed to make sure a tragedy like this can never, ever happen again. So let's get right into it. How in the world does a common kitchen staple transform into a powerful explosive fuel? Well, the answer is all in the science of dust. Okay, so what exactly is combustible dust? Well, the U.S. Occupational Safety and Health Administration, you know them as OSHA, they define it as pretty much any fine material that can catch fire and explode when it's mixed up in the air. And to give you a sense of scale, we're talking about particles that are usually less than 420 microns. Think about the size of fine table salt. And you'd be surprised how many workplaces have this hazard lurking around. I mean, common examples are things like sugar and flour in food processing, wood dust in sawmills, grain dust in silos, even fine metal dusts from grinding aluminum or magnesium. They all share this same hidden explosive potential. Right. To really get why this happens, we need to talk about surface area. So let's do a little thought experiment. Imagine you have 1 kilogram of sugar, and it's all packed into a solid sphere. Its surface area is tiny, right? Just 0.048 square meters. There's not much surface exposed to react with oxygen, so it's not going to burn easily. Okay, but now, this is the crucial part. What happens when you grind that same kilogram of sugar into a fine dust? The total exposed surface area literally explodes to 120 square meters. That's a 2,500-fold increase. And all that massive surface area means each tiny particle can react with oxygen almost instantly. It's what turns a slow burn into a violent explosion. Now, for this potential to actually become a disaster, 5 specific things have to be present all at the same time. Safety pros call this the Dust Explosion Pentagon. Think of it like a recipe. First, you need your fuel, that's the combustible dust. Then, you need oxygen, which of course is all around us in the air. Third, an ignition source, a spark, an overheated motor, something hot. And here are the last 2 critical ingredients for an explosion. The dust have to be dispersed, floating in a cloud, and that cloud has to be in a confined space. The takeaway here is huge. If you can remove just one of those 5 elements, the explosion simply can't happen. But here's the thing that makes these incidents so incredibly dangerous. The true destructive power usually isn't from that first little ignition. It's from the chain reaction that comes after it, something we call the secondary explosion effect. This is the part that turns a small, maybe containable problem into an absolute catastrophe. So let's break that down. You have what's called the primary explosion. This is often pretty small. Maybe it happens inside a piece of equipment like a conveyor belt. But the real danger, the big one, is the secondary explosion. This is a massive, cascading blast that's fueled by all the dust that gets violently shaken loose from rafters, pipes, and floors by the shockwave from that first smaller event. Imagine how this deadly sequence unfolds. It starts small. Maybe an overheated motor ignites a little pocket of dust inside a machine. Poof. But that initial blast sends a pressure wave, a shock wave, through the whole building. And that wave is powerful enough to knock loose years of accumulated fine dust from every single overhead surface. Instantly, you have an enormous, fuel-rich dust cloud filling the entire facility. And when the flame from that first blast hits this massive new fuel source, well, that's when you get the devastating secondary explosion that can literally level buildings. And that, right there, is why this is so critical. When investigators look at these disasters, they consistently find the same thing. It's the secondary explosions that cause the most fatalities and the greatest destruction. So preventing that initial dust from building up in the first place, that is the absolute key to stopping the chain reaction before it even has a chance to start. Okay, so to see how all these scientific principles combine in a real-world disaster, we have to look at the Imperial Sugar Explosion. It is a textbook and deeply tragic example of this science in action. Back on February 7th, 2008, that series of explosions just completely destroyed the Imperial Sugar facility. And the human cost was just staggering. 14 workers lost their lives and 36 more were critically injured. Everything we've just talked about, all of that science, it all played out in just a matter of seconds. And when investigators looked into it, they saw exactly how the company's safety failures directly fed each and every element of that Dust Explosion Pentagon. You had poor housekeeping, so there was fuel, sugar dust, absolutely everywhere. The dust collection systems were ineffective, which allowed for dispersion. The ignition source, a single overheated conveyor bearing. And the enclosed conveyors and buildings, they provided the perfect confinement. Every single piece of the deadly Pentagon was in place, just waiting. The investigation into this totally preventable tragedy really highlighted some critical gaps in safety, and that led to a renewed focus on solutions. And that brings us to OSHA's prevention and control standards. That's right. In fact, as a direct result of the Imperial Sugar catastrophe, OSHA reissued its Combustible Dust National Emphasis Program, they call it the NEP, in March of 2008, just a month later. This program basically ramped up enforcement and inspections in any industry with a high risk for dust explosions, making it a top priority for the agency. So what do these standards look like? Well, OSHA and industry standards focus on a multi-layered approach to prevention. It all starts with really rigorous housekeeping to get rid of the fuel. Then you need engineering controls, like powerful dust collection systems to prevent dispersion and things like explosion venting to get rid of that confinement. Of course, you have to have strict control over any ignition sources, and maybe most critically, facilities are required to conduct a formal dust hazard analysis, or a DHA, to really proactively identify and control their own specific risks. All right, this brings us to what might be the most practical part of this whole explainer. What does this actually look like in your workplace? And what is your role in preventing the next disaster? So I want to ask you a very direct question. Think about it. Have you ever walked through a plant, a factory, or even a workshop and seen that fine layer of dust coating the overhead pipes, the rafters, or sitting on top of the machines? If you just answered yes to that, then you have seen the fuel for a secondary explosion just sitting there waiting for a trigger. This is so much more than just a sign of poor cleaning. It is a critical red flag for a catastrophic hazard. In fact, that is exactly what an OSHA inspector is trained to look for as a sign of imminent danger. It's that silent waiting fuel load that can turn one small incident into a deadly one. So let's wrap this up with the most crucial point. Combustible dust is one of the most powerful and frankly underestimated hazards in all of manufacturing. The science is crystal clear, and as we've seen, the consequences are devastating. But, and this is the most important but, with proper housekeeping, with the right engineering controls, and with a vigilant safety culture, these disasters are completely 100% preventable. So if this explainer helped you get a better handle on real OSHA hazards and the science behind them,
then subscribe to HSEstudy. We'll help you learn OSHA standards, dig into real accident investigations, and discover life-saving workplace safety strategies.